let's talk about the idea of finding the region between the area of a region between two curves in the plane, which is a very interesting problem. In essence, we've actually talked about this in the past, the idea that if we have a curve in the x and y axis system, such as the one like f of x right here, and we look at that curve's the way it goes, we look at the way f of x goes, we can say between a and b there is an area under the curve when we take its integral. That is, we're looking at essentially the displacement of the function, and if the curve is completely above the x-axis, we call that geometrically the area under the curve. Visually, this is actually a very appealing kind of problem because we think about this idea that, well, if we wanted to actually find the region between the two curves, we should think of this as a subtraction operation. That is, if we have an area under the curve, if we just pull out some, right, some of our dx strips right here, so we think of ourselves as having a strip of width dx, right, and we're taking the summation of all of these infinite dx strips underneath our curve. If we go from under f of x and we take away a little bit of it, right? We take away this piece from g of x. Let's just put that aside. What's left, of course, under the curve of f of x is what would be left for us under between the curves of f of x and g of x. So we put that strip over here and we see that, well, sure, that is our area between these two curves, right? We're just looking for the summation of all of those strips right here. So we just think of this as an accumulation of all of these, and we're going to have ourselves an area between the curves f of x and the lower curve g of x by taking away the area under g of x. Well, more formally, we think of this strip of width dx representing all of those curves right here. And let me go back and snag my little piece of my curve right here if I can do it. The wonders of technology here. Oh, come on. We think of all of these dx strips that we can put underneath the curve, and suddenly we have the idea of this curve being the accumulation of those as a summation. And formally, from the Riemann sum, if we take the limit as n approaches infinity from I equals 1 to n of f of x sub I minus g of x sub I times delta x, we can think of that as the definite integral of the difference between f of x and g of x dx. So formally, we do want to say that if we are on a closed interval from a to b, and the function g of x is less than or equal to f of x for all the x on the interval from a to b, then the area bounded by the two graphs of f and g and the line x equals a and x equals b will be given as the definite integral from a to b of f of x minus g of x dx. Well, let's take a very straightforward kind of example right here. Let's say that we're interested in the area between the curves f of x equals x squared plus 1 and g of x equals 2x. Well, here's our two curves right here, f of x being the top curve, our parabola right here, and g of x being the straight line y equals 2x. And we're interested in this area that is going to fall between these two curves in this little section right here, starting at 0 and ending at 1. So what could we say about this area right here? Well, according to our formula, this is going to be the antiderivative evaluated from 0 to 1, that is the definite integral, of the curve x squared plus 1 minus 2x dx. Well, we do a little bit of simplification right here just to make it a little bit easier on ourselves. We see it's from 0 to 1, x squared minus 2x plus 1 plus 1 dx. This is a kind of curve that we have evaluated before as a definite integral, and we get 1/3 x cubed minus x squared plus x, and we're going to evaluate the interval from 0 to 1. Well, that gives us 1/3 times 1 cubed minus 1 squared plus 1 minus 1/3 times 0 cubed minus 0 squared plus 0. I don't need to tell you that just goes all to 0 right here. And of course, 1/3, we subtract 1, but we add 1 on the same level right there. And of course, we're going to get our area of 1/3. So this is how we can evaluate this in the simplest possible form. All right, more to come.